Despite what some on the internet have recently claimed, the 3 magnitude 4 range earthquakes which struck Iran in the last week were not the result of nuclear weapons tests or related massive explosions. Instead, they were 100% tectonic, all occurring in a region with strong yearly compression due to the collision of 2 tectonic plates. But, you might say, couldn't a nuclear weapons test just happens to be held in such location anyways? I mean, sure, but there are a number of factors which make it absolutely impossible for anyone, and I mean anyone in the world, to detonate a nuclear weapon and for us scientists not to know about it. While people, politicians, and governments can lie, the scientific data cannot. And the scientific data currently shows that the earthquakes which struck southern Iran on March 3rd, 6th, and 7th of 2026 were purely tectonic. I know this by simply looking at the earthquake waveforms which were recorded by many seismic stations outside of Iran. For context, when an earthquake occurs, 2 main types of seismic body waves are generated, an S wave and a P wave. The P wave moves faster and causes less damage, while the S wave moves more slowly and causes more severe earthquake damage. For tectonic earthquakes, the S wave has a notably higher maximum amplitude than the P wave when it arrives at a seismic station. And this is exactly what was observed from Iran's 3 earthquakes, an S wave stronger than its P wave counterpart. If any of these Iran earthquakes were to have instead hypothetically originated from a nuclear weapons explosion, the relationship would have been the opposite, with the highest amplitude waveform being from the P wave. This is not just true for nuclear explosions, but large conventional explosions as well. In fact, the nature of various seismic events and their waveforms are why, if you were to go on the US Geological Survey website, you can not only search for seismic events that are typical earthquakes, but also mining explosions, rock bursts, landslides, conventional explosions, nuclear explosions, ice quakes, large volcanic eruptions, and even meteorites entering the atmosphere or impacting Earth. My second piece of evidence relates to the earthquake epicenter depths. Almost all nuclear tests which have occurred have resulted in epicenters being registered of 0 km depth, essentially indicating an explosion on the surface, or more commonly not too far below ground. In contrast, Iran's 3 earthquakes all had epicenters at 10 km depth. And yes, while 10 kilometers is a placeholder value, it is fairly obvious if a specific magnitude earthquake had an epicenter near the surface versus multiple kilometers underground. Third, for an underground nuclear test, the resulting earthquake equivalent magnitude that is registered has a fairly predictable relationship to a specific kiloton or megaton TNT yield. And yet, there is no evidence of any radioactivity release or subsidence craters that often form after such underground tests. Fourth, the area is absolutely filled with faults, and I mapped possible faults and lineaments which could have been the source of these quakes. After all, just look at the frequency of various magnitude earthquakes in Iran. It is quite tectonically active as a nation. Now, normally, I would show a piece of evidence known as a moment tensor that shows the relative motion from a top-down view of what generated a seismic event. While the most common earthquake types create moment tensors like this, explosions create a moment tensor that is either completely solid blue or almost entirely solid blue. We saw this exact moment tensor appear during North Korea's September 3, 2017 underground nuclear test, which had a yield of around 250 kilotons or 250,000 tons of TNT. Remember, the reason why nuclear weapons explosions show up as earthquakes on seismometers is that anything that causes sudden motions of rock releases seismic waves, and these waves can subsequently be detected. The only problem is that the Iranian earthquake data site seems to be currently down, and outside detection networks only generate moment tensors for earthquakes greater than either magnitude 4.5 or 5.0 in Iran, but none of these earthquakes fall into that range. So, we don't actually know what their moment tensors look like, but I sincerely doubt they are anything but reverse fault, thrust fault, or strike slip related. So once again, these earthquakes did not originate from a nuclear test, they just represent typical seismicity in a seismically active country. As a final note, I would like to thank this channel's patrons on Patreon and channel members on YouTube for supporting my work.